Are you guys ready to talk about it? And again, if you're not quite, just kind of come back and we'll just make sure we're all kind of on the same page with the questions. Some I left not finished just because I want you to help me circle the right answer, for the ones where you guys had to do the matching questions. Okay. So with the first one, did you guys have any problems? Because it told you the words to use. Do you guys agree with what I did? Climbing, resting, climbing, descending, resting, climbing, resting. Is that what you guys wrote as well? Right, was it easy to tell which word to use in each spot? Okay. Because again, please make sure that when you guys are looking at these relationships, that you look at what the axes are labeled to make sure that you're using proper words, right? So this is a time versus distance from base, right? So they're definitely, right, climbing and descending, obviously, if it's coming back down and so forth, okay? So here, did you guys write something? Can you guys tell where they're climbing? So any section that you list as climbing, could you use the graph to determine where the person was climbing the fastest? So hopefully, do you guys agree? Steeper the line, the faster they're climbing. Do you know why? Perfect. It's less time, right? If there's a steeper line, that means they're covering more ground in less time. So that's probably why they're going faster, right? So that's perfect. You're looking at the time, right? So then what would you add to the graph to show the climber's return to the bottom of the cliff? Obviously, you would show what kind of a line? Right, a descending line, okay? Is this possible? Depends, were they falling off? You may not survive. That's possible? Yeah. Did they fall? Wait, no, time needs to be moving. Time still has to be moving. So even if they fall, do we still have to cover some time? Yes. So is that possible? No. So I always put that up there because people automatically look at that and go, oh, they fell off the cliff. Nope, they didn't. That's not possible. There has to be, does that make sense now, guys? There has to be a little bit of a slant. That's why I put in a slanted line, definitely descending for it to be possible, okay? So that line has to have, again, this would still be bad, right? If I put just a tiny bit of a slant, that would still be very bad, right? That's probably maybe them falling, okay? So obviously coming down, we want more of a slant, means more time is being covered, which means that they're hopefully descending at a safe rate, right? Right, unless they got to the top and they parachuted down, even that would take more time, right? So something like that.
Giant trampoline at the bottom.
Yeah, that would be interesting, right? And that's the thing too here. Do we know that they climbed actually very high? No, because there's no units, right? It might be a tiny little hill. We have no idea, right? Unless there started to be units. We don't know if it's a mountain or if it's just literally a hill or anything, right? All right, so this is the one I didn't want to match because I want you guys to tell me what you guys matched. So we have 4 different things being discussed or give descriptions, and they want us to match the best graph to match the description. So the first one says the temperature of a cup of hot chocolate over time. So what graph did you guys match that one with? Does everybody agree with C? Yes. Right, so that one I agree because we should end up having a very hot, temperature's hot, right? Over time it should decrease, okay? A car accelerating to a constant speed. Oh, so I heard a few things. So I heard A, I heard D, I heard what? B? Okay. So it accelerates then to a constant speed. Does that make sense? Right? So there is an acceleration. So it definitely has to be B. Good. If it just said a constant speed, then could it be D? Yes. So for 3, a distance a person walks during a hike. Right? Exactly. Well, and again,
could you kind of make this graph work for C?
Well, it was just from
Exactly.
the spot.
So if you labeled these axes differently, you could make A work, but since we want to put one graph with one description, let's do the best fit graph, right? So the best fit graph would definitely be D, right? A distance a person walks during a hike. And like I said, if you wrote this one on a quiz and then explained why, the thing is, if we only could use one, could you make this one though, graph D?
Yes. Like if you cut it off, like once it hits its apex.
Right. So again, you could argue these two, but you would have to explain why you did it. It's not the best fit graph, because you could argue this, but then yeah, it never comes down. It basically, like you said, hits its max height, right? And then you're assuming that it's actually kicked at a constant rate, which, right, usually a ball kind of accelerates. But again, if you argued those things with and explained what you guys are saying with me, for sure. Okay. But the best fit, do you guys agree, is CBDA? Those would be the best fit scenarios for those graphs without having to really change the context, right? Of, you know, assuming the ball doesn't drop to the ground and stuff like that. Okay. All right, so here, hopefully you guys read through this, okay? The biggest thing I want you guys to understand that if something's describing something that is moving at a constant rate, it needs to be described or shown in the graph by a straight line. Does that make sense? So that's so important. So a constant rate, straight line. If it's increasing, obviously a positive slope. If it's decreasing, decelerating, right, it'll be a negative slope. Have you guys talked about slope and stuff in science yet? Right. We're going to talk about it in this unit. And you should have talked about it in grade 9. I just don't know how much your teacher went into it. But so right now, just, are we good with a straight line? So if something's at a constant, running at a constant rate, it needs to be shown by a straight line. Okay. And this one you guys seen in the graph already. A horizontal line means that there is no rate of change. Have you guys discussed rate of change as slope as well? Rate of change is another way to describe slope. Okay. So there's no rate of change, right? So time, right? We're not moving, things like that. Horizontal line. And then if there's not a constant, right, movement, then you're going to have a curved line, right? So not constant. So curve shows that the rate of change is not constant. So it's not changing by the same amount. All right, so again, hopefully you read that. You didn't need to highlight any of it, but all right, so almost done here. So which graph best represents bacteria growth? If the bacteria food supply is limited, explain your choice. What did you say, Samantha?
I chose C because it starts stable and then it has a sharp increase. But after a while, after that sharp increase, it sort of diminishes over time.
Exactly.
Because we're dying.
And that's the key. It does say that bacteria is dying, right? So the only graph that shows a decrease at the end is C. Right? I shouldn't say they say it's dying, but what word there or what part of that sentence should have made you assume they were? Right. Food supply is limited. Right, and then this one's always interesting. Okay. Which graph represents a person's height as person ages? Okay, so let's do a show of hands. So I heard B. Okay, so I'm just going to put numbers underneath. How many say B? So 1, 2, so lots. How many say A? How many say C? So about 5. How many say D? Okay, about 3. Did anybody say A? Okay, nobody says A. So this is always a very interesting conversation, okay? Because normally it ends up kind of being Actually, all three of these, you guys did pretty much what every other class does, okay? So let's just talk about in general what these would mean. Okay, so if I go here, it's saying that right from birth, what happens?
Sharp increase in height, start growing really fast.
But is this kind of constant?
Yeah.
Yeah, so it's basically saying from birth, I grow at a constant rate. Is that true?
Not at all.
No. Think of a baby from like 1 to 2 years old. Do they grow really quick? Yeah. Yeah. Well, even, and think about this, guys. Like when you're little, you grow quite quickly. Like you have growth spurts, right? So the younger years, you grow a lot faster than you do when you kind of hit your teenage years. Boys are a little bit different. Some of them, have their spurts a little bit later. Usually, sadly, us women kind of are done. Not all the time, but are kind of done by 14, right? That's kind of when the growth plates kind of start closing, where a lot of times boys, guess what? That's when they have their big growth spurts from 14 to say 17. Not always. This is not yet, sometimes. So, and again, that's not always the case, right? My daughter's still hoping she's going to grow more, but I don't think she is, okay? So that's why this one, I get it, but this piece right here is a problem. Because if you think from when you are born, right until you hit maturity, then what happens? It looks like that we're starting to start dropping for quite a while, okay? Which hopefully is not true. I'm not there yet, okay? But usually it's more like the spine and stuff is why people end up actually being not as tall as they were. But this says they keep shrinking for a while, okay? And that, hope to God, is not the truth. So this is the problem for sure here, is this piece here from when we're born to when we kind of reach our max height is not a constant rate.
Yep. It also argue another issue is saying when you're old, you're going to be nearly half as tall as you were.
Oh, yeah. Actually, if you look at that.
I feel like it's a bit extreme.
No, I agree with that, yeah.
It's an inch or two, but not that much.
Yeah, so a little bit, yeah, about 3/4 height, which is, yeah, definitely not true. Inch or two is exactly right. So that's why I get why people think this, right, when you first think. So let's X-nay that one. So this one, all right, says, so this one here is actually saying what at the beginning? Right, you're growing, but slowly, right? And then all of a sudden, you grow really quickly, and then instantly, as soon as you reach your max height, you start shrinking. Okay, so is that true? No. Right? So is that kind of making sense, guys, as you kind of pick each piece of the graph? So this graph B here, definitely right at the beginning, there's a little bit of a sharp growth spurt. And then it's still pretty good, right? But it still starts to be a little bit, so I would say this is after like the 14 kind of, depending on, male, female, genetics, all that kind of stuff, right? But this is kind of up till the, quick growth years. And then we grow a little bit, and then we hit a plateau, right? And we hopefully stay that same height for quite a while, right? Hopefully into our at least 70s, hopefully. And then we might decrease in height a tiny bit. So to me, winner, chicken dinner will be graph B. But I love having this conversation every year just because once you start looking closely, especially since these axes, right, were labeled, right, then you can actually pick each piece apart, right, as you talk through them. All right, and then this one just says, Josephine leaves her home and walks to the store. After buying a drink, she slowly jogs to her friend's house. Josephine visits her friend for a while and then runs directly home. Using the distance show, draw a distance time graph that shows Josephine's distance from her house. Label your axes and explain each section of the graph. So I just copied, pasted this. So this was time in, doesn't say, and this is distance. So I didn't label these. So distance from her house. So does yours look similar to this, guys? And again, does it have to be perfect? All right, it doesn't have, because you don't know, like this you might not have did as long as mine, but it does say there's, the only thing that I would really look at it is the sharpness of the line, right? Because the walking line better not be as steep as the running or jogging line. As long as you make sure that this one, right, versus this one, and jog versus run, they probably could be pretty similar, right? But as long as this line, the first line, isn't as steep as the running jogging line, that's kind of what I'm looking for, right? And then the resting spots, right? So hopefully this one, the first horizontal line, does it make sense that that one should be shorter than the second horizontal line? Because the first one she's just stopping at the store, and the second one isn't she visiting her friend, right? Which hopefully would be longer, right, than a quick stop. And you're done. Okay. So normally I could easily do 2 lessons today, but we just wrote our exam. I don't want to do that, and I do want to give you guys your exams back. So in your assignment book, you guys can go ahead and just do a few more of these, play around with these questions. When you're done that, I'm going to hand your exams out right now. But please finish this first, and then you may as well get your corrections done today. That way, if you ever do want to do a rewrite, even if you don't feel like you want to right now, it's just done, because then I can write done on the front, and then I can check that off of the to-do list.